Okay, so we've gone through insulation, we've gone through airtightness, we've gone through thermal bridge free. Now we are on to windows and doors. Basically, windows are, normally, they just let light in. But with a passive house certified window, they can actually become, on the south side, a net heat gain over the heating season, which means they are part of your heating system. These are a few examples of different passive house certified windows. Inotech, one of our sponsors, Veta West, another one of our sponsors, and then Pazzi. So when I say certified passive house window, what I mean is that that company has paid Passive House International in Germany money to test their window to the same European standard, which is actually more stringent than the North American standard, that every other window is certified to. So I'll test it the same thing, and you end up with a basically a certification that gives you all of the data that myself as an energy modeler need to put it into PHP correctly. And then when you certify it, you also get that certificate, and then it actually gets put into the PHPP online database, and it actually gets put directly into PHP Energy Model, so I don't actually have to ask for any stuff. I just pick it from a drop-down menu. So it makes it really easy. But obviously there is an upfront cost to that and an ongoing cost to stay in the system. So and there's a cost to that. So what a lot of suppliers have done is they have maybe one Passive House certified window, and they have another window that's Passive House verified, which just means they paid them once to test it and give us a sheet. It's not the formal certificate, but it's still like a sheet that gives you all the values to enter into PHPP. So again, I can trust it, and it doesn't cost them as much. An uncertified window, like a North American triple pane window, the glass can be the same. 4 or 5 years ago when I built my house, I imported my windows from Europe because North American glass wasn't quite as good. But now the North American glass is just as good as European glass. So again, it can be with the right films and the right gases in it. You can get triple pane glass in a normal frame that is R11, R9 center of glass. And if you ask a non-certified window installer or a non-certified window supplier what the R value of his window is, he will tell you the glass because it's the highest. What he won't want to tell you is all the other parts. So what makes up a Passive House certified window? So I don't know if you've all ever looked at a residential window, but it doesn't look like this. So again, there's 3 panes of glass. There can be various films on various surfaces of the glass. Then you have a spacer that maintains the space between these 3 panes of glass. In between the glass, there's also gas. Generally it's generally it's argon. Krypton is a little more expensive, but a little more R value. Then you have your frame. And the reason the frame still gets a fairly good R value is all this insulation in it. So a higher performing frame will just have more insulation. More of these spaces will be a sealed air cavity as opposed to an open air cavity. And then the other thing is when you open it, which is tougher on sample. Oh, yeah, that's why. There we go. You will see that there is always at least 2, often 3 seals. So 1, 2, and actually 3 seals. So that's how you get the air tightness. And the other thing is that here on the sample, there's already 1, 2, 3 points. But on a bigger window, you'll probably have 6 or 8 or 10 of these multi-point locking locations. So that means that when you close the window and have a bigger handle, it pulls it in and sucks it in on all these multi-point locking. And that's how you ensure that you get an airtight window all around. Where you just have a standard window that has a little crank at the bottom, yeah, the crank might pull in that corner of the window in, but all the other corners might be flapping around and who knows. So that's kind of the difference between a uncertified and a certified window. Another thing to worry about is the spacers between the glass. You obviously want those to be insulative. So this looks like metal, and normally you say, oh my God, it's metal, it can't be insulative. It's stainless steel. Stainless steel does not conduct heat very well. So a plastic or a foam spacer might be better than the steel spacer, but Inotech uses stainless steel spacers because the stainless steel, it's strong, so you get more structure out of it. So it's all a trade-off. You get the numbers, you put the numbers into your calculation and you can compare them. But if this was an aluminum spacer, no, that'd be horrible. But stainless steel is fine. Foam and plastic is sometimes better, sometimes not, because you don't get structure. And then when you get your windows certified, you also get it certified for a climate. Because again, different climates need different windows. You don't need a super insulating window when it's always 20 degrees outside. So most of the windows are cool temperate climate certified, which is kind of a Vancouver climate. The only one that's cold certified is P.Eng. Technically, our climate is cold. We technically should be using the P.Eng window. But it's expensive, and when you actually put it into the energy model, you can use the Inotex and the Vetas with no problem. And again, the windows I have in my house, I've had for 3 or 4 years, are temperate climate. So there is a potential that you might get a little bit of moisture at the bottom of the window if it's minus like 30 and cloudy for a few days. But as looking at these windows, and these actually aren't even certified passive house windows, it doesn't happen very often. On my window, that big 5 by 10 window, I have an R3 insulated blind that I will close at night. And if it's minus 30 outside and I have R3 insulation on the inside of the window, yeah, when I open that blind for like a half hour, I get a little bit of moisture. But like it can't be that good. I'm not letting the heat from the house out to the glass. The glass will eventually get cold. But again, 20 minutes after the blind is up, it goes away. And with the fiberglass frames or a PVC frame, that little bit of moisture will never do any damage. There are also wood frames with aluminum cladding on the outside. Wood, I would never use wood on a window on the outside. I would always clad it with aluminum because that's more durable. But if you like the look of wood on the inside, you can use that. So some of the windows are what's called a tilt and turn function. It's kind of a European function that is coming over here. So tilt and turn means that when you turn it halfway, you pull the top of the window in, and the top of the window comes in a little bit. That's the tilt function. What that gives you is it gives you enough ventilation coming in through the top of the windows and kind of the cracks you created all the way around, but without physically breaking the window, it is still secure. People can't get in, it is still secure, and because it's tilted at the top and still fairly sealed at the bottom, it keeps all the weather out. So you can open the tilt window open in the summer, leave the house. If it rains, you don't care. The weather will stay out, and someone won't be able to break in. And then it has the turn function, which is turning the handle another 90 degrees, and then the whole window opens in, which makes it really easy to clean, because you just clean the outside glass from standing in your house, and it gives you a nice big opening if there's a fire or whatever that you want to get out. Yeah. So you do have to worry that you have to make sure you don't have a faucet right there. And if you do put plants, you might have to move the plants. But again, 90% of the time you're tilting. So then you can still have something on your windowsill. Really the only time you open it is if you want to clean it or if you want a lot of ventilation. There are obviously tilt and turn doors and certified passive house doors. I personally would be a little hesitant to get a tilt and turn door just because those doors are big, they're heavy. I do trust that the mechanism won't fail, but it's a lot of weight. Just put an operable window right beside it if you need your ventilation, or Inotech and a few other people have really nice like phantom screens built into the frame. So if you need ventilation, just open your door the whole way, put your bug screen closed, and don't worry about that tilt function. So the reason you want this high quality window is this. If your window is not high enough quality, the temperature of the window will drop to 15 or below, and that kind of 5-degree temperature change is when we as humans start to feel a draft. That's what we feel a draft as. As long as the temperature is kind of above 15, which most passive house windows will be in all temperatures, you won't feel a draft. So that's why you want the high quality windows, because then you can go and sit right in your window at any time. You could put like a window well or a reading nook in your window, and it's not uncomfortable at any time. So the next thing about windows is, again, we want them to be, the south side ones, we want to be heaters. So the sun is at a lower angle in the winter and heat your house. You don't want that to happen in the summer. In the summer, when we get hot, one of the things we can do is we can step into the shade. So what we want our house to be is we want our house to be in the shade the whole summer. If we did not shade our south windows and we let the sun into our house in the summer, we are going to overheat because we've made a thermos that sun's heat will overheat the house. You see there's always large overhangs on the south windows because the sun in the summer is high in the sky. So you can calculate that, how big of overhang you need so that your building is in the shade in the summer, but still lets enough sun in the winter. So now this is kind of where you put your windows on the various sides. So obviously if you see the sun, if you're shaded out on the sun side, then you don't worry about it. But on the south side, if you see the sun, you want to let the sun in. So you want the majority of your windows on the south side. So in this passive house, they have 61% of their windows on the south side. If you look on the north side, they only have 15%. So basically the windows on the north are just enough to give you probably fire exit from your bedrooms and good daylighting to all those rooms. So in my house, and that house looks about the same, a 4x4 window will give you all the light you will need, definitely meet your fire exit requirements, but not be too big to be losing more heat. So the next thing is east windows. So east windows, there's like basically one. In my house, I have no east windows. And this house has 21% west windows, which is normally too much. The reason you don't want many east or west windows is because in the summer, that's where the sun sets and rises. And it actually sets about 30 degrees north. So it would be coming into those south or east and west windows for a long time in the morning and in the evening, and will likely overheat your house. And you can't shade it by an overhang. So the reason that house doesn't overheat because of the 21% of west windows is there's a house there. So those windows never see the sun. So your east and west windows, if you do need them for like a view or another reason, you want to look at alternative shading methods for those locations, such as exterior shades. You could put an exterior blind on the window. Innotek sells one that you can mount it to the outside of the window to shade it from the outside. You can't use a blind on the inside because the heat's already in the house. You've got to keep it on the outside of the house. So an exterior blind, deciduous trees, or another, what I use on my house is like a shade fabric screen that in the summer I put a screen on some of my windows. And it's like bus wrap, it's like 80% sun shading. So now that we have built an airtight, well-insulated, thermal bridge-free building, we can no longer breathe through the cracks in the wall, which is really what we're doing, especially in the summer, in our code minimum houses. Because in the summer, generally the furnace fan turns off, and the furnace fan has some amount of outside air that it's blowing through the house. But if your furnace fan isn't running, you are literally breathing through the cracks in your walls, which means you don't know what you're breathing, because you don't know what happens to be in that wall, and you don't know what is being blown out of the wall, and it's not being filtered or anything. So what passive oxygen says is now that you've built that airtight house, you need to mechanically ventilate it. And you mechanically ventilate it through what is called a heat recovery ventilator. So a heat recovery ventilator uses basically through a heat exchanger, it scavenges the heat off of the exhaust air and uses it to warm up the supply air. And in addition to that, you want that mechanical HRV to be continuous, filtered, balanced, silenced, and commissioned. So what do all those things mean? So continuous just means that it runs 24/7. It never turns off. It is always providing you fresh outside air to your house. And it supplies that air into your living rooms and bedrooms where you're living, and it exhausts at the same time from your kitchens and your bathrooms. So that where the contaminants are being made or the smells are being made, that is being sucked away right now. Whereas now in a code minimum house, you probably have a supply air in your bathroom. So if your furnace kicks on when you're in the bathroom, you are now pushing your contaminants through your whole house, which isn't the best thing. So that's continuous. The next is filtered. You want to get high indoor air quality, you need to filter the air. So there is always a filter on both the supply and the return side of the ERV or HRV. And generally that is a MERV 13 or so on the supply air. It's a little lower on the exhaust air, because really in the exhaust air you just want to keep the pet hair, the dandruff, the dead skin out of the core. And that MERV 13 as we saw in the video, is generally pretty good at keeping out smoke. But if you have a really high sensitivity to smoke, or if you think there's going to be a longer term or longer amount of smoke, then what you could do is put an additional filter box before the HRV that 90% of the time is left free, but you have a carbon filter or a HEPA filter that if it is really smoky and you're concerned, you slide that in at that point. The reason you don't want to leave that carbon filter in all the time is the MERV 13 filters for HRVs are washable. So you can pull them out if you buy at least two. So you pull one out, put the new other one in, you go wash the other one, and then they last kind of a year or so, and they're about $30. Your carbon filter or your HEPA filter is a one-time use, can't clean it, and it probably costs you $100. But if you put that in, nothing's getting through. So it depends. Like on my house, the first time we had smoke, I didn't really notice anything. The second year we had smoke, I did start to notice some smoke. So it depends. So the other thing is, this is a HRV. So the moisture is not recovered. All it is it's transferring the heat from the supply air, from the exhaust air into the supply air. But what you might want in a drier, colder climate, definitely Calgary, maybe Edmonton, you might want what's called an ERV. All it changes is it changes the core. So it pulls out a core that's just aluminum and puts in a core that's essentially Gore-Tex. So it allows a transfer, no cross-contamination, but allows a transfer of both heat and moisture from the exhaust air back into the supply air. So in Calgary, where it's always dry, it's nice because that allows some of the moisture that from your showers or cooking pasta or people breathing, instead of it all going out, some of it comes back into your house, and it allows you to keep your house above kind of 30% relative humidity, even in the winter. In Edmonton, before I started to talk to some of the net zero builders in Edmonton, I would have said use an ERV here, but it seems that your summers are a bit more humid, so sometimes you might want to just stick with an HRV because you might have too much humidity problems in the summer. It also depends, like if it's a bigger building with less occupants, and the occupants say shower at work, then you might want the ERV because there's no moisture production. If it's a smaller, kind of more multi-family where there's more people in smaller spaces, they're cooking at home more, they're showering at home more, there's more humidity produced, then you might want just the HRV. It is just a core swap. The difference at the beginning is only $200, but if you want to swap out your HRV core and put an ERV core, it's about $1,000 because the core is expensive. So, I don't know. In Calgary, I say always ERV. In Edmonton, I used to say always ERV. Now I'm not sure. But this is kind of what it's doing. In the winter, the heat is exchanging and you're scavenging that heat. In the summer, you don't want that because you want to get rid of all the heat, and especially in Alberta, it's very good at cooling off in the evenings. So it's what's called a summer bypass. So in the summer, it still goes through the filters, but it doesn't go through the core. It just goes straight through. So you can be bringing in that cooler air in the summer in the evenings to do what's called nighttime cooling. So in addition to mechanical ventilation, you can use what's called natural ventilation, and that's opening your windows. So this is my house, the south side. I have a window in my kitchen, and I have a window upstairs in my open loft. So if I open those two windows in the evening when it started to cool off, because heat rises from the stacked effect, the hot air will always be exhausted out the top, and I'll always be pulling in cool air into the bottom. The other nice thing about my house are my bedrooms are actually on the main floor, and I have operable windows in my bedrooms. So if my bedrooms do get warm, they're on the north side, they generally don't, but if they do get too warm, I just open up that higher window, open up the main floor window, and I'm drawing cool air directly into my bedroom and exhausting the hot air up the top. If you only have one story, you can open windows on opposite walls or opposite elevations, but you don't know exactly which one's going to be the in and which one's going to be the out. It depends which way the wind's blowing, or which way the temperature is different, or which way the pressure is different. So it works better if you have an elevation difference. It does work if you don't. And actually, if you have a tall enough single window on the tilt function, it can exhaust hot air at the top and pull colder air into the bottom. with just a single window, but it needs to have some height to it. The one other part of this is you can't rely on mechanical ventilation when it's smoky. If it's smoky out, you don't want to open your windows because that's defeating the whole purpose and letting it all in. So in the PHPP, there is a section that allows you to calculate the nighttime cooling from natural ventilation opening your windows. And that will affect how much your house might overheat. But because of the smoke, I always say, turn that option off and see what your house performs at. If you rely on that and it's smoky, you're in trouble. So always, you can account for it, but always see what happens if it can't be used. So those are the 5 design principles. That's kind of the science and the application of the science and the physics on how you get all those benefits we talked about earlier. So I've talked briefly about some of the performance standards. So Passive House is a performance-based system. These are the performance metrics. So it limits the total energy you can use for heating and cooling to 15 kilowatt hours per year per meter square of interior space. So that's that limit. And this is the 90% reduction because the Canadian average is 150. So you go from 150 to 15. It then limits your total energy consumption. So that's everything. That's heating, that's cooling, that's plug loads, that's lights, that's appliances, that's everything. It limits that to 120 kilowatt hours per year per meter square of space inside your house. So that just makes sure you're not wasteful everywhere. Next thing is your air tightness. So it limits you to 0.6 air changes per hour. Again, your code is 3.2. And then it actually requires comfort. It requires the ASHRAE standards of comfort, which is, among other things, that no surface on your building, no interior surface of your building can be below 16 degrees. So by ensuring that, you ensure that nowhere are you ever going to get condensation inside your house, which means nowhere are you ever going to get mold. Or very unlikely to get mold. And then the last one, it limits the overheating. So it says your house can't be over 25 degrees. Officially it's 10%, because that works in Germany. We're sunnier here a lot more, so we are saying that it should be less than 5%, or if you don't have any mechanical cooling, 0. Because the climate is getting warmer, not colder, so it might be 5% now, in 10 years might be 8%, in 20 years might be 20%. So it might not, but you don't know what it's going to be, so you don't want to be already too high. My house was designed at 8% because it was one of the first ones we didn't know. It was still less than 10. I thought it would be great at 8. 8 is too much. It means like probably 15 or 20 days, it's 25 degrees or plus, and under 25, yeah, you don't really notice it. Above 25, yeah, you start to feel hot. So that's basically the envelope. The inside is whatever you want. And again, you can hang whatever you want on the outside, make it look as pretty as you want, different textures, different materials. You're just hanging it on the outside of the building. If you actually go and look at these buildings, they are basically a perfect rectangular square box. They have some really nice balconies and such hung off of it, but it's a square box. But yeah, it's an energy standard. How you do it, it's not prescriptive. What materials you use, how you get to those prescriptive standards is up to you and your designers. So here are some Canadian examples of passive house buildings. So we have, in Nelson, BC, we have a 3-family, multifamily building. They put a whole bunch of decks all the way around it, but structurally, or building envelope-wise, it's a square box. It's a 3-family, kind of the owner, I think it's a mother-in-law suite, and then a rental suite. So obviously the sound transfer is always important on that one, but that's what you get. Then another one in Comox, BC, it's a single-family home. Again, relatively simple square box, but you add on some nice finishes on the outside and some shading to give it some architectural features. Another one in Quebec, same thing, three-unit multifamily, actually might be the same design, very similar, but square box, fairly easy to tell which way it's south, and correct overhangs on the south windows so they don't overheat in the summer. Again, it's not only for houses, these are some larger multifamilies. So this is the one in Ottawa. It's a 42-unit LEED Platinum as well as Passive House, so again, dual certification. It's a care home for patients with mental illness. It's a not-for-profit developer. It's using textures, different colors to create your architecture feature. Next one over, Hamilton, Ontario. This was actually inner fit, so we'll learn about what that is in a little bit. But that is a renovation. That's a renovated building where they took it from an old, probably office or an old whatever, and turned it into, again, affordable housing built to the Passive House standard. So you can do renovations. Last one, location is Fort St. John. Again, it's another 57-unit affordable housing partnership with BC Hydro and BC Housing. Passive House and affordable housing is kind of a match made in heaven. And it's also, again, not just low story. This is bigger buildings. So in BC, this one's just proposed, but it's a 136 condo and 34 rental unit, mass timber CLT Passive House ply scraper, as they call it. So plywood skyscraper. Another one, 43 and 48 story Passive House. And this third one, the Ken Solby Tower, it is again another inner fit renovation. So it was like one of the old like 1970s tower. There's actually a fair amount of them around kind of all over the place. What they're doing is they're totally taking off the envelope, putting a whole new envelope, a new Passive House envelope onto the old building, updating the mechanicals, putting a few more kind of community spaces, public spaces, amenity spaces around the base, but kind of reinvigorating what was becoming an older building, but still had really good structure and bones. So instead of demolishing and starting over, they are renovating an existing. Now a little closer to home, these are Alberta. So this is this is the first one in Alberta. It's only recently got certified, like about 6 months ago. But it's in Fort Saskatchewan. 2015 they moved in. So the cost, that's building only, no land. The above grade is if you don't include the basement. That's kind of how we buy and sell houses now with above grade square footage. But I put in the developed square footage because like especially that one's a walkout. So there is obviously some cost to develop a walkout basement. And a lot of people say that passive houses have to look weird. That's the driveway side of a passive house. And it looks exactly like any other house in that subdivision. So they don't have to look weird. And again, it's pretty easy to tell which area is south on that building. And air changes, 0.3. On the inside, so that's kind of the R values of the walls and the roofs and the structure. They used poly vapor barrier, but they used a Siga high performance tape, so it can be done. They did have an installation cavity, so it wasn't damaged by future renovations. And it's kind of a double stud blown cellulose, dense packed cellulose wall. They also had a little bit of overheating. Similar to me, they probably designed closer to the 10% as opposed to kind of the 5 or under. So they have added additional blinds on the exterior to control the overheating. This is my house. So 2016 I moved in, and that's obviously the south side. That's my main floor kitchen. So I have kind of an 1.5 to 2 inch concrete topping on the main floor that adds thermal mass to my house. We haven't talked about thermal mass, but what it is basically anything that's heavy inside the building. It's best as if the sun actually directly hits it, and what that thermal mass does is it absorbs the heat, so it reduces the fluctuations from the sun's heat coming into the house. So if you have a building with a slightly higher thermal mass, the sun's heat will be absorbed by that thermal mass. You won't overheat in the day, and then when the sun goes down or stops shining, the concrete will radiate the heat back throughout the night. $575. It was $450,000 of hard costs for me to build the building. That's what I paid other people. The other $125 I've put in kind of for my labor, me being the general, and my father was also on site. I was a little about 0.3 on air changes, and I added the solar panel array after I moved in when the credit came out. There's my walls. So again, R40s, R30s below grade. I have R60 roof, 7.2 kilowatt array, I have rainwater harvesting. I have a very nice orientation. I'm only 16 degrees off of true south and not much shading. And I put in kind of permaculture food forest on the north side to kind of grow more increasing amount of food on my lot. I don't have any lawn. On the south I have annual beds landscape in to grow some more garden veggies. And I had 8% overheating, so what I've done is I've added some shade fabric screens on my south side to get my overheating down to about 5. This is the one house greenhouse in Calgary. This was the first certified passive house. Costs are a little higher, a little more higher end finishes. Same H range is 0.4. So that 0.6 sounds scary, but it really isn't. Our values and walls are starting to look kind of similar. Again, they added a solar array afterwards once the credit came in before it left. This is another one house green building. So this is a non-ideal lot. So the lot runs east-west, so south is the neighboring building. So if you can see, because of that, the only part of the building that sees the sun is the upper second floor. So obviously their ability to obtain heat from the sun is reduced. It was a very high-end finishes, so that's why the cost was higher. But if you look at the R values, their walls are R55. They basically have to add another 3 inches of rock sill to account for not having as big of sun, not as much sun. So it can be done if you don't see the sun. It's just, again, a little more insulation. And they did do small in-floor heat and electric boiler. Most passive houses don't. But again, they're missing some of that 30% of heat from the sun. So then a boiler, an in-floor heat better meets the demand. This is an off-grid passive house. This is CLT, the same designer as the Brookfield passive house, the same materials as the passive house. Again, it's homeowner built, so he's got kind of the $226 per square foot. He'd probably have to add a little bit more of that to include his labor. Air change is 0.3, so again, still doing very good. Because they're off-grid, their walls and roof and slab are a bit bigger. He's got a 7.8 kilowatt array plus 24 deep cycle batteries. But the other big thing is he's got a large solar thermal array. And he's actually got 5 rows of it here. He's actually taking 2 or 3 of those rows down because that solar thermal array was producing too much hot water. And he does have under his slab, remember I talked about putting PEX under the slab, so he has PEX under his slab, and he dumps the excess heat into that in the summer and in the fall, but he was finding he just had too much heat. He couldn't dump it fast enough, so he took down some of his solar thermal. But he also still needs, because he's off-grid, he still needs a fairly large cistern. Actually, the cistern is there because he actually doesn't have a well. He's 100% rainwater harvesting as well. So whether or not that was because the well had to be very deep to hit water, or if he's concerned about contamination of the well water. If you don't have those concerns, a well is cheaper than a cistern. But you can survive off of 100% rainwater harvesting. And he's also putting in permaculture food for us to kind of grow his own food. Kind of what we've learned from this building is that unless you're about $50,000 to $100,000 connection fee from the electrical grid, connect to the electrical grid. Or unless you think the zombie apocalypse is coming and the grid is going to fail, then go off grid. But if you don't have either of those two kind of requirements, connect to the electrical grid. It's about $100, $180, $200 to annual connection fee to electrical grid, so that's a pretty cheap battery. And basically you use the grid as the battery. You sell your excess when you have excess, and you take as much as you need when you need it. Because when the worst kind of time for a passive house is if it's cold and cloudy. If it's cold and sunny, you'll be fine. But if it's like minus 15, minus 20, and cloudy for 5 days, your solar panels aren't producing, your solar thermal isn't really producing, and you're not getting much heat from your house, that's when you might need your backup generator to kick in. So that's when it would be nice if you could start pulling more energy from the grid. So, but it can be done. They are living quite happily. And again, it's 100% all upfront costs, and after that, the maintenance costs are pretty much zero. This is the Valley View Town Hall. We're going to learn a little bit more about this in the cost section. But this was the first commercial Passive House Plus, and we'll learn what that is in a bit. And it's in Valley View, which is even north of us. It's near Grand Prairie. Passive House Plus basically means you are net zero. So they have a bigger 28 kilowatt array, but that gets their town hall to net zero. And there's some big numbers in our values, but our climate is cold. Their climate is Arctic. But again, it's all blown cellulose, which is pretty cheap. It is justified. Habitat Studios in Edmonton is an excellent net zero builder. Peter Morangon was the principal of it. He's since left to move on to Butterwick, which we'll see in a bit. But he used Passive House energy model in the background, but designed to net zero. But again, his numbers are pretty close. Like, it's not really that far off of Passive House. He uses 0.1 air change instead of 0.6, but yeah, it's really not that far off. This is another EcoHaven one, so this is Dave Spencer. Dave Spencer is the developer of EcoHaven. This is his house. Yeah, fairly good air tightness, surprisingly large numbers for the walls, R values. It's just the way it was designed. It's, and I guess another slightly older one, so there wasn't as much optimization on exactly how much insulation is too much. So that's kind of, definitely not all of the ones, but a good cross-section of how it's been done in Alberta to date. So this is one other movie about how another builder put it all together.
Passive house takes advantage of one of the most abundant resources that Alberta actually has, which is the sun. So you can see that this house is actually orientated along its east-west axis, and the giant window in the middle there is actually the furnace for the house. So we have phenomenal insulation blanketing the whole home all the way underneath the foundation and everything. We also have incredibly airtight building envelope, so much so that there's very little energy needed to heat and cool the home.
Welcome to Green Energy Futures, your guide to the green energy revolution that's already underway. New homes could be required to be super energy efficient, net zero ready as early as 2030. Brookfield Residential wanted to learn more about building super energy efficient homes, so they set out to build the most energy efficient, most beautiful home they could.
Hi, welcome to the Brookfield Passive House.
There's been few jaws drop as soon as they walk in. I don't think it's because it's a passive house. I think it's because it's beautiful.
This is the Tesla of passive homes, requiring 90% less energy than a conventional home. It's heated and powered almost entirely by the sun.
We have basically the furnace, which is the big window in the middle. All the glazing is facing south, the windows, right? And then on top of the roof line, we have a standing seam metal roof system, and we have 8 kilowatt of PV solar installed up there.
The secret sauce in this passive house is top to bottom super insulation.
It's incredibly well insulated. So if you go piece by piece, you start with the windows. These windows are about R7, okay? And typical windows are about R2. If you went to the wall systems, R45 compared to an effective R18 being required. Roof systems about R55 compared to a cathedral ceiling, which we're required to have R10. So a dramatic difference, so much so that it changes the mechanical in the home.
Even at 2,400 square feet, this home does not have a furnace.
From there, we move to the ERV, or the Energy Recovery Ventilation System. This is in place of a furnace, so the home does not have a furnace. And I don't know if you can tell right now, but it's running, so it's incredibly quiet. And then there's a little toaster up there, or a hair dryer, so that when it is too cold in February, it comes on and does what it needs to do. But these are your lungs, and this is in place of the furnace.
Yes, this home is heated by the equivalent of a toaster installed in line with an energy recovery ventilator. The ERV recovers heat that otherwise would be lost when bringing fresh air into the nearly airtight home.
So 86% of the heat it will recover, so air that we're exhausting from the house will scavenge 86% of the heat on that to warm up the air coming in.
Passive House standards set goals for energy efficiency, but don't prescribe how to do it. This home has one other pretty cool feature we don't see often in North America. It's built out of 4-inch thick cross-laminated timber, or CLT.
CLT product is, it's a great sustainable resource. It's a natural material, and it's the insulation that we've selected. The wood fiber board on the outside is a byproduct of the manufacturing process for the CLT. Ultimately, you get another good environmental story out of that.
This means the interior walls of the home are beautiful solid wood, and almost no heat is lost through the 16-inch thick walls.
This is cross-laminated timber. It is 4 inches thick of timber that's been glued together and laminated together, and it creates the structure of the wall. At the end product, you install this insulation 9.5-inch layer plus the 1.5-inch layer, which will give you R45 value of insulation. This wall will be strapped with 3/4 inches of plywood, and then the siding is put on the outside.
The result, a beautiful, super energy efficient home. Doug Owen says code and policy trends clearly point to a future in which homes need to be super energy efficient.
it doesn't matter whether it's Alberta, Canada, North America, globally there's a conversation around energy efficiency, resiliency, conservation. I mean, there's a tremendous amount of momentum behind it.
Alberta's no stranger to energy-efficient homes, but this one will be one of just a few in Alberta certified to the rigorous Passive House standard.
We have to learn how to localize it and create this local industry that's going to really decrease the cost of building these types of homes and build a type of industry in Alberta that not only allows us to live efficiently and comfortably, but also creates jobs and economic opportunities for Albertans.
It's undeniably cool to sit in a luxurious 2,400 square foot estate home that is heated by the equivalent of a hairdryer. Perhaps it's the quiet of the home or the warm floors in the basement. The whole place just feels cozy. Want more details? Check out our blog, podcast, and photos at greenenergyfutures.ca. For Green Energy Futures, I'm David Dodge.